All right. Hello, everybody. It's good to see you here and be with you on this beautiful fall evening. My name is Brenna Marsachek. I'm the Communications and Outreach Director at Madison Audubon. And before we get started tonight, I'm going to give you just a quick introduction to Madison Audubon for those of you who are new to our community. We are a Wisconsin nonprofit that's working with members like you to protect birds and nature in this area. We do that through land restoration. We have about 2,000 acres that are free and open for anyone to visit. We do that through citizen science and advocacy, through youth and adult education programming. Maybe you've tuned into one of our online lessons this year. And we do that often through events. We host a lot of events normally, and this Evenings with Audubon program is one of those events. But of course, you're joining us now from the comfort and safety of your home, and we're grateful to have you here. Tonight, we are delighted to host Jeremy Cohen to share info about some really important, really timely research that he just published studying the effects of extreme weather on birds using the wealth of data in eBird. Jeremy is a postdoc researcher at UW-Madison in the Forest and Wildlife Ecology Department. He's also a fantastic nature photographer, a very good butterfly catcher and monarch tagger, and an all-around really good guy. Before I hand it over, I just want to make a quick note about how we'll do this. So Jeremy will give his presentation for about 40 minutes or so. If you have any questions along the way, please type them into the comments box, and at the end of his talk, I'll read Jeremy all of your questions and we'll get his insight right away. If you're watching this after the live recording, you can also type in your questions and we'll get to those as soon as we can. So with that, I'll hand it over, and Jeremy, you can take it away.
Thank you. Thanks for the introduction, and thanks to everyone who's watching. Brenna, I just wanted to note that I don't currently have the full screen open, so if I share right now, I can only share the non-full screen version. I think if you take this off, and then if I, I think if you remove me from, actually, if I stop sharing here and then share again, I think I can do this.
Okay.
Cool. All right, all set. Before I start, I just wanted to acknowledge all of the people that were involved in this work. On the left here is Dr. Ben Zuckerberg, who's a faculty at the University of Wisconsin, who I work under. And on the right is Dr. Daniel Fink. He's a statistician at the Cornell Lab of Ornithology. And so without the two of them, this work would definitely not be possible. So big thanks to both of them. Big thanks to the University of Wisconsin and the Cornell Lab of Ornithology. And then NASA and eBird for providing the data for the study. The nuthatch did not explicitly help on its own, but it's pretty, so I threw it on the slide also. So birds, if you are watching this right now, you probably have some affinity for birds in some way. So why might that be the case? There's a couple of reasons, I think, that kind of stand out as to why birds are so popular. As you can see from these images, they're very, very colorful. So they're bright, they have all these different colors, they're very attractive. A second reason that people are so into birds, I think, is that they're very obvious. So what that means is that birds kind of stand out as opposed to other wildlife. They're very active during the day. They're hanging out in the trees where you can easily see them. And they can afford to do that because they have wings, so they can easily escape if they're threatened. Whereas stuff like reptiles, amphibians, they tend to hide under logs. They're not quite as visible. Mammals, tend to be more nocturnal, so they are less visible during the day. But birds tend to be much more obvious. They're much easier to see when you're out and about. And then the third reason I think that birds are so exciting and so popular is that they're so diverse. So this is just a figure showing the amount of different taxa, the amount of species of different taxa in Wisconsin. So there's about 285 bird species that regularly occur in Wisconsin. There's about 150 fish, but obviously these are a lot less easy to see because they're underwater. Um, about 65 mammals. I can only say that I've seen maybe 10 or 15 different species of mammals in Wisconsin. They're super secretive. And then only a couple reptiles and amphibians. But you can pretty much go out on a spring day and find 50 species of birds without too much trouble. So they're super diverse and they have all these different forms that make them really popular. So scientists noticed this pretty quickly, and they've developed a couple strategies to, take advantage of the fact that birds are so popular and that so many people are recording in great detail the amount of birds that they see in different places at different times. So what they've done is structure these different programs called citizen science programs. And the purpose of these programs is to collect all this data from regular people, non-scientists who are collecting data anyway, just for fun, and then use it in order to find out more about what birds are doing. And so eBird is an example of probably the example of a citizen science initiative. And it's called semi-structured. And what that means is that um, there's some structure to the data, but it's pretty flexible. So people have the flexibility to go out, um, look at birds wherever they want to look at them and at whatever time they want to do it, how often they want to do it, for whatever length of time that they want to do it. So there's a huge amount of flexibility that people have. And eBird at this point has over 650 million records that have been contributed. So a really major citizen science initiative run by the Cornell Lab of Ornithology. I'm guessing a lot of people watching this have probably used eBird before, but just in case you haven't, this is a little bit of an outdated look at the app, but you can essentially choose the location that you're birding, record all the birds that you see and how many birds there are of each species that you've seen. And one thing eBird does that's really nice is it organizes the app so that you can, so that it shows you the most common birds in the area for that time period. So you can very easily find the birds that you're likely seeing. And then this turns out this is a really important component of eBird. It spits back data to the user showing how many birds you've seen in different locations and in different years and different months. So the reason I say that that's so important is that because before eBird did this in like 2001, 2002, when it first came out, it really wasn't catching on with people. But once they started feeding back data to all the users and keeping track of all these different lists during different years and different months and different locations, it really caught on and became much more popular with people and grew into what it is today. And I'll confess that it definitely motivates me to submit more data to eBird. So this is my map of the US in my account. As you can see, Wisconsin is the darkest color, so I've seen the most species in Wisconsin. And it really just motivates me when I'm traveling, I'm on a road trip or something like that, to go out and visit a bunch of parks in some new area, whether it's rural or urban or whatever, and try to find as many bird species as I can just to make this map light up more. And so now I'll show you some of the capabilities of eBird data and what's been done with the data. So if you open a more traditional field guide, you'll see something that looks like this. This is a distribution map for Magnolia Warbler. This is a very pretty warbler that passes through Madison in May and then in September, October during migration. So if you look at the distribution map here, this range, you'll see that it breeds in the boreal forests and northern temperate forests. It migrates through the eastern United States, and then it winters in Central America and the Caribbean in blue. And so with eBird, we can create something that looks more like this. And so you can see the resolution on this map is much, much greater than anything we've had with the traditional species distribution map. So if you look at areas like Appalachia, New England, or the Western Boreal Zone at the edges of the ranges, you can see much, much greater detail in where the species is occurring. And that's true for the wintering areas as well. So you can see that not all areas of Central America have this bird wintering. And so at first glance, if you look at the left and the right side of this, they kind of do look similar to each other. But if you're, a manager of a park in one of these areas, it's really important to know whether this bird is expected to occur and in what frequency. So if you zoom into the map, you're getting much, much greater detail than you are on the left side. So now I'm going to try an animation and hopefully it works. So another really cool thing we can do with this species and with many, many other species is look at the abundance trends over time throughout the year. And so I'll play this, and you can see the slider on the right side. I'm scrolling through January, February, March, April, May. They all shoot up through the eastern United States. September, they're all coming back down, and then through to December, back where we started. So I'll just play that one more time. I've played these on a loop for 10 minutes at a time. I could stare at these all day. They're just so cool. But you can really see every single week of the year. I'll just play it one more time. Where Magnolia warblers are expected to occur and be abundant. So super, super cool. We could never do this with traditional field guides before. This has been done by eBird for hundreds of species. Oops. Okay, there we go. And one last example that I'll provide with eBird data is looking at the trends over time for a lot of these species. So they've produced a number of maps that look like this. And this is an example with wood thrush. So you can see that the red points on the map are areas where the wood thrush is declining, and the larger the red circle, the greater decline in that spot. And then the blue areas are areas where the wood thrush is increasing. And this is since 2007. The black outline is the full range of the wood thrush, the breeding range. So this is one of the most popular birds in popular media. So half the time when I hear a bird singing in a movie or a TV show, it's the wood thrush. So really, really notable bird in eastern forests. The good news on this map is that it looks like in the upper Midwest, especially Wisconsin and Minnesota, you're seeing some more increases of wood thrush, which is great. But obviously in a lot of the eastern US, you're seeing pretty strong declines of wood thrush. And wood thrush is not alone with these declines. So there was a study that came out last year from the Cornell Lab of Ornithology, and it showed that we've lost about 3 billion birds out of, I think, 12 or 15 billion, something like that, since 1970. And that's just a figure here with year on the x-axis, the horizontal axis, and the change in birds on the y-axis, showing that there's pretty steep declines during this period. And this panel of the figure breaks it down by different habitat types. Don't worry about what they are yet, but I just want you to notice on this panel that there's some habitat types where birds are holding on pretty strong. They haven't really changed that much. They might have declined a little bit, but there's also a good deal of habitat types where birds have declined pretty strongly since 1970. And then in this panel, you can tie each line to each habitat type. The best news is with wetlands. So there's been a lot of important work done in wetland restoration. A lot of wetlands that were drained in the mid part of last century have been restored. And there's been a lot of protection for ducks and egrets and other birds like that. So wetland birds are doing decently since 1970. But grassland birds especially are doing pretty poorly. And then forest birds are not doing so well either. And so why might this be the case? So there's a number of factors that are involved in bird mortality each year. And unfortunately, even though I love them, cats are responsible for a lot of this mortality each year. So this is the number of birds each year that are lost to these different factors. So outdoor cats, they tend to be kind of killing machines, not just of birds, but small mammals. If you're down south, lizards, stuff like that as well, reptiles. So I have 2 cats of my own. They're strictly indoors. I love cats. So I sometimes get in trouble for saying this, but yeah, outdoor cats can be pretty devastating when it comes to birds. Another big factor that's pretty well known is collisions with buildings. So birds collide with buildings, especially during migration each spring and fall, and that's a cause of a lot of mortality. And then collision with vehicles, being accidentally poisoned, other types of collisions. And one thing that tends to that tends to pop into a lot of people's minds when they think about bird mortality is wind turbines. But as you can see from this figure, the relative contribution of wind turbines is it's very, very low compared to many other factors. So it's so low you can't even see the bar in comparison with the bar for cats. So wind turbines have pretty bad reputation, but they're not really contributing in a major way to bird deaths. And so what can we do to protect birds? You might have seen some variation of this figure before, but one thing is keep cats indoors, make windows safer by putting stickers on windows so the birds know that they're windows and not just open air. Using native plants in your garden, so that way the birds have access to food and shelter that they need with native plants. With non-native plants, they don't really know what to do with those plants. Doing citizen science is another one, so contributing to eBird and other types of citizen science. But those are some simple actions. One more complicated action is doing something about climate change. Obviously, this is not something that one person can or should be responsible for on their own. We can all do a little bit to help, but really it's a societal problem where we're going to need our government to step up and take action to really combat climate change. So this is just a little bit of a comic. Wait a second, what are you grass and birds doing so high up in the mountains? It's a high elevation bird over there saying that, and then the low elevation bird is coming up and saying, meet our friend climate change. So that's in reference to the fact that birds have been observed moving upslope, so higher up in mountains, as climate change has progressed. We've seen that many species of birds have been moving not just higher up mountains, but also to higher latitudes. And so in the United States, this is just an illustration of how different species of birds have been changing their wintering ranges with climate change since the 1960s. And you can see for all these different species, big changes in their ranges, their wintering ranges with climate change. So lots of movement, most of it's north, sometimes east or west, but pretty commonly they're moving north with climate change because the winters are just more tolerable. So it doesn't make as much sense for them to migrate. So that's one major impact of climate change on birds. Another second impact of climate change on birds that's been really well studied in the last 20 years is changes in phenology. Phenology is the annual timing of some behavior in birds or some event. So that could refer to migration, could refer to nesting, egg laying, hatching, any of those things. Those have all been shifting earlier for a wide variety of taxa, but they've been shifting slower for birds. And so some birds have been observed, changing the dates to keep up with the earlier springs, but not a lot of birds have been observed doing that compared with other taxa. And unfortunately, one of the taxa that tends to be shifting earlier and earlier very quickly is insects. And insects are a very important food source for birds when they're migrating and when they're feeding their fledglings. So what we've been seeing with climate change is that a lot of these birds are showing up and the insects have already peaked 2 weeks ago, or the birds, their nestlings are hatching and the insects have already peaked last week or 2 weeks ago. So they're not quite keeping up with their prey, which is a bit of an issue. All right, this one played without me even having to do anything. So this is simply a time-lapse progression of changes in mean temperature globally. And you can see that the blue colors are colder temperatures relative to a 100-year average in the 20th century. The orange temperatures are a above average condition relative to the last 100 years. And so this one stops at 2013. You can see that over time, the colors have been getting warmer and warmer. I'll just play it one more time in case you missed it. And the year is ticking towards the bottom here. So as this progresses, big changes in global temperatures, and not evenly everywhere. So there are some areas that haven't changed much, but there are other areas that have changed quite a bit. And that's true, especially at the Northern Hemisphere. You can see that when this stops at the end here, the Northern Hemisphere is warming quite a bit faster than other parts of the world, especially the high Northern Hemisphere. So that stopped at 2013, but it would have looked a little bit more glaring if we had gone past that point to 2020, because the last 6 years have been the hottest years on record ever. So, and the last 5 years have also been the hottest 5 years on record ever. So you can see that the last 5 years have been well over a degree on average warmer across the world than the previous 100 years. 2016 was the warmest. And you can see this trend regardless of whichever temperature measurement you look at. So these are 5 independent measurements across the world. And there's definitely some variation between them, but overall the increasing pattern persists. And so this is another figure where you have year on the x-axis temperature in these blue and red bars. And all these figures I should say are relative to an average. So they're taking the 100-year average and then looking at what's the difference each year from that average. And it's overlaid with CO2 concentrations. I'm not going to go into too much detail about that, but very strong relationship, obviously, between CO2 concentrations in the atmosphere and climate change. But that average that's usually cited is a little bit misleading because there's definitely major differences depending on where you are and when you're talking about as well. So just to give an example, this is temperature change in the United States in the last 100 years, I think. And if you're in the Southeast, you might not really know that much is going on at all unless you're in South Florida. There really hasn't been much in terms of temperature increase in a lot of the Southeast. Very slight changes in both cold and hot directions. But if you're in the Southwest or if you're in most of the northern US, there have been pretty strong changes above 1.5 degrees Celsius, which is above 3 degrees Fahrenheit. So for a lot of these areas. And that's true in Wisconsin definitely as well. So that's overall temperature increases, which might not seem like a lot, just a couple degrees. But what does it mean for extreme weather, which is the focus of what I researched? So if you imagine that this is just a distribution of temperatures in a given climate, so it's average temperature a lot of the time. Sometimes it'll be a little bit colder, sometimes it'll be a little bit hotter, but more infrequently. And then all the way at the end of this curve, in the beginning of the curve, there's a couple of cases where it's extremely cold. These cases occur relatively small slice of the time. And then that's true at the hot end as well. So there's a very small slice of this curve that's extremely hot also. So let's take this curve and just slide it over so that we're increasing the overall temperature. And now try to look at the new curve and how it overlays with cold and hot extremes. So you can see that with the new curve, there's very rarely extreme cold conditions anymore. But there's now many, many times more extreme hot conditions than there were previously. So just a very slight increase in the overall mean causes these really extreme hot conditions occurring all the way on the right side here in the red color. And for us, it might, cause disasters in like the 2003 heat wave in Europe, where there's quite a bit of mortality among people because it's too hot for the infrastructure is not built for people to withstand that heat. But it also really affects wildlife. So wildlife have to be, outdoors the entire time when it's hot. And if it's outside what they can tolerate for a really long enough period, then that's really going to affect their ability to persist in that environment. And so scientists have looked into this quite a bit and found that there's a number of different extreme events that are increasing with climate change. So those include droughts, extreme precipitation events, flooding, and heat waves. Those have all increased quite a bit with climate change. Hurricanes and tornadoes, the evidence is a little more limited and mixed. There's some evidence with hurricanes. Tornadoes, I'm not sure if I've heard some, but for all these other events, they're increasing. So our question was, how are species responding to this extreme weather rather than just climate change as a whole? But we're especially interested in this extreme weather aspect. And so our more specific goals were to explain how extreme weather impacts the presence of a bunch of different species, 109 species. We looked at a wide range of different groups of birds. So by groups, I mean birds that vary in diet, so seed eaters versus insect eaters, long distance migrants versus residents, small body size birds versus large body size birds, And then number two, across different time periods. So we wanted to know whether, okay, you have a heat wave, but if it's only 2 days, is that going to have the same effect on birds as really extreme heat conditions over the course of a month? Maybe it takes a longer period of time for them to really be affected. So we used eBird obviously for this analysis, and it has a couple of strengths. So one of the big strengths is the massive data volume. As I said, 650 million contributions. It's got this really, really great resolution. So we can look at differences in these types of different answers to these types of questions in different areas of space and in time. And one really important feature of eBird, if you've used it, you're familiar with this, is that it encourages you to submit complete checklists. And what that means is the checklists are recording every single species of bird that you've observed while you've been operating. So rather than just record whichever species you tend to be your favorites or whichever ones you feel like recording, you're recording every single bird that you've noticed. And that way we can infer which species were not there along with which ones were there. And when you're talking about looking at the effects of extreme weather, it's really important to know what's not there rather than in addition to what is there. We want to know when birds are not present. And some of the challenges with eBird, there's biases in space and time. So a lot of areas like Central Park in New York City, or Milwaukee and Madison versus other parts of Wisconsin, those are sampled much more often than other places. And so we don't want those to overwhelm the entire analysis. And variation in observers. So I like to think that I'm decent at finding birds, but I might be able to only find 75% of the birds that are actually out at a park that I'm at. I'm friends with a couple of people who are real experts who are probably finding 95% of the birds. If it's there, they're going to find it. There's other people who might be a little bit more novice, so they might only be able to notice some of the birds that are there. And then variation in effort. So not all checklists are recorded for the same amount of time or over the same distance. So there's a lot of variation with that. There's other data sources as well. Audubon Christmas count that's been going on for over 100 years, and the Wisconsin Breeding Bird Atlas. Both of those are really great and have contributed to a lot of research that's been done for sure. For our purposes, we wanted to be able to look at bird responses immediately following extreme weather. And so rather than use these data sources, which are recorded about once a year, we wanted to make use of eBird's continuous recording of data so that there would always be lots of data available immediately after each extreme event occurs. And so we used weather data from NASA during the month of June. We picked the month of June because we wanted all of the breeding birds to be present, but we didn't want to worry about the effects of migration on whether birds would be detected or not. So we focused on June when birds are kind of settled into their breeding territories. And we used DayMet, which is a data source from NASA, satellite data source, to look at, to tie that into the eBird data set and figure out how birds are responding to extreme weather. So we gathered maximum daily temperature and total precipitation for every single one of 800,000 plus checklists during the month of June in the eastern United States. So a huge amount of data. And we gathered them at 3 time periods, summarized over the week before each checklist, the month before each checklist, and the 90 days before each checklist. And we did this for all of these 800,000 plus checklists. And so this is just a visual representation of DayMet, just an example, so that you can see it has really, really high, impressive spatial resolution. It's been collected since 1980. So this is just daily total precipitation in 2012, just as an example. And so you can really see what kind of resolution it has. So what do extremes look like? So this is something I produced, just a typical average day across our region, which is the eastern United States and Canada. So obviously there's tremendous variation in what an average day looks like for across this region. South Texas is going to be very hot on an average day, whereas central Canada is going to be pretty cold on an average day in June. On an extreme cold day, so a second percentile day in each of these pixels, this is what it looks like. So obviously, um, very, very cold on an extreme cold day in Canada, and then still kind of hot in South Texas and Florida on an extreme cold day. And then on an extreme hot day, um, you're seeing that this kind of evens out a bit more across the map, but still major differences if you're talking about northern Minnesota versus South Texas. An extreme hot day in each of those regions is going to be pretty different. So we wanted to account for the region itself when we were talking about what is an extreme. And so this is important because later I'll be presenting um, how birds responded to what I'm calling an extreme hot, week or month or 90-day period. And so that varies across different, and what that actually means across states. So just a reminder of our goals, our two main goals. We're looking across different groups of birds and across different time periods to see how extreme weather impacts birds. And so we had a couple of hypotheses. We figured that northern residents and short distance migrants would be most sensitive to heat. And the reason for this is that, they're used to typical conditions up north. They're equipped to survive the winters here. So they're a little bit more cold tolerant, but they're not necessarily used to very hot conditions up north. We expected that neotropical migrants, so the birds that go all the way to Central America and South America, these birds would not be as sensitive to extreme heat. And that's because they're spending half the year in the tropics. So even though it's the dry season, they're experiencing very hot conditions for a large part of the year. So they should be more adapted to that. We figured that seed eaters would be more sensitive to heat and insect eaters less sensitive because insect eaters are pursuing insects, which tend to be more active on those hot days. So insect eaters, we assumed less sensitive to heat. And then we figured that larger body size birds, those would be less sensitive just because they have what's called thermal inertia. So it takes more time for their body temperature to change when temperatures are fluctuating. And just to give some perspective on how we interpret the results of eBird checklists. So there's these different temporal scales that we're measuring extreme weather over, weeks, months, and seasons. And so heat waves tend to occur over the span of a week. A dry spell or flooding could occur over the span of a month, or an extended heat wave. And then over the seasons, you could have drought or shifts in productivity. And without getting lost in all the text here, I apologize for all the text. Just kind of focus on those big colored words. So we're expecting behavioral changes over the course of a week, demographic changes such as die-offs over the course of a month, and then something more like a distributional change over the course of the season. I'm just going to kind of gloss over this just because it's a little bit complex, but we looked at whether or not birds were observed on a given checklist in response to a couple of different factors. The two focal ones were the daily temperature and precipitation. And that was summarized over those 3 time scales, so a week, a month, or 90 days. And then we included a bunch of other factors that were important. Land cover is obviously very important in dictating where birds occur, because some birds will only occur in wetlands, some birds will only occur in forests. So we had that in the models as well. Topography, some birds will only occur at high elevations or low elevations. Observer effort and variation as recorded by eBird, which I explained before. And then time of day, because that affects which birds are out, and the year, because some birds are increasing or decreasing in their occurrence over time. And so I'm just going to show you a few of these figures, but they're all the same. So we have the temperature anomaly on the X horizontal axis. So on the left side, that's going to be cooler temperatures, and then on the right side is higher temperatures. And then just occurrence of these species on the y-axis. And so for a lot of these really common species that you see every single day in your backyard, they really weren't too much affected by temperature, which we kind of expected. So if you go out and you're submitting an eBird checklist, you're pretty much going to find these guys regardless of whether it's hot, cold, or whatever. So we didn't really find much of an impact of temperature. But for some of our resident birds right here, like goldfinch, housefinch, chickadee, crow, we found that they were occurring when it was a little bit cooler on those cooler June days, but when it got really hot, they tended to occur much less often. So you can see on the right side of all of these figures for these 4 species, a major dip down in occurrence for when it gets pretty hot. Species that were less sensitive to heat were some of those neotropical migrants, as I mentioned earlier. So you can see when on those cold June days, they were actually not really out and about so much. But when it was warmer, they were out in droves. So they were actually most excited by those warm days. So that's true for common yellowthroat, great-crested flycatcher, Baltimore oriole, black and white warbler. So some of those neotropical migrants that winter in the tropics. A couple more showing the exact same pattern: red-eyed vireo, white-eyed vireo, eastern wood pewee, yellow warbler. So again, some of these insect-eating long-distance migrants. And then we also looked at trends in relation to precipitation. So now on the left side of each of these plots, you're going to be seeing extreme dry conditions, and then at the right side of each of these plots, extreme wet conditions. And so there was a lot of variation, as you can see, with these 4 species. Parulas really tended to prefer the wetter time periods and were occurring less often at the dry periods. The phoebe and gnatcatcher were also sensitive to both dry periods and wet periods and were occurring most often in the middle there when it was kind of average. And then the yellow warbler dipped down a little bit when it was dry, but dipped down a bit more when it was a little bit more wet. And then if I have time for this, just to show you some overall trends. So on this plot, every single one of these dots is one of the 109 species that we looked at. And so we could look across all of these different birds and look at, on the x-axis here, birds that don't migrate at all, so have 0 migration distance, versus birds that migrate up to 4,000 kilometers. So they have a really large migration distance. They're migrating to the tropics. And we found that those long distance migrants, they're not really changing their occurrence too much. So their occurrence is still remaining pretty high, as you can see on the y-axis there. But the occurrence is a bit lower when you're looking at those birds that don't migrate very far. So they were the most affected by extreme heat. Looking at the effects of diet, as we predicted, invertebrates and also omnivores were tended to be occurring still at kind of high rates after extreme heat, but those seed eaters and fish eaters tended to be occurring less often. The fruit eaters were also kind of high, but I think that was only based on like 2 species, so I wouldn't put too much stock into that one. But the birds that are essentially not eating very many insects, those are the birds that are occurring less often when it's less hot, when it's hot. So the thinking there is that those invertebrates and omnivores eaters are the ones chasing insects on those hot days. And then finally, this is the last one, last figure I'll show. Less common birds tend to be sensitive to drought. And that's especially true at these monthly and seasonal scales in the middle panel and the right panel. So on the x-axis, we have commonness, and that's just kind of a score we came up with to assess how common birds tended to be in their prevalence. With 0 meaning they occur on no checklists, or 0.01 meaning they're on about 1% of the checklists, and then 0.5 meaning that they're about on half the checklists that are submitted. And then on the y-axis, we have, once again, occurrence. So those really common birds that are always on checklists, those are occurring at relatively higher rates when there is drought compared to those birds that are less common. And the reason we think that's true is because those less common birds tend to be a little bit more specialized. So when the drought's occurring, they could lose a food source, they could lose the habitat that they need, whereas those generalist birds that are super common, they can just move to the next food source or the next habitat. They don't really care. It doesn't matter too much to them. And so we did some kind of cool stuff where we created maps of a species distribution and how it's affected by extreme heat. So this is just an example of Carolina chickadee, which is a very close relative to our black-capped chickadee. And we found that in a lot of the core of its range, which is most of the deep south and the Carolinas, there was kind of only a minor decrease in the presence of chickadees after extreme heat, but in those parts of the edge of the range, such as those northern areas or those South Texas areas, um, the birds were suffering a lot more after extreme heat and occurring 30% less than they typically were. I'm going to skip this slide for time. And so just to recap with some conclusions, um, short distance migrants and residents are sensitive to extreme heat over days and weeks. Non-insect eaters are sensitive to extreme heat over days and weeks as well. And then less common species, usually specialists, those are the ones that are sensitive to extreme dry conditions over the span of months. So just a little bit about what we're doing now after this work's been completed. I just submitted another manuscript to a journal for publication, looking at how birds are affected by extreme weather during the winter. And we focused on events this time rather than temperature anomalies. So we looked at what birds are doing immediately after something like a polar vortex in 2014. That was a devastating event where temperatures were extremely cold. Polar vortex is kind of an interesting case. I'm not going to go into too much detail about it, but even though that's an extreme cold event, there's a few complicated mechanisms that are causing the polar vortex to become more common with climate change as well. If someone wants to ask about that, I could go into more detail about that. And then the second project we're working on is looking at how tolerance of extreme weather changes across different seasons. So are certain birds more tolerant of extreme heat maybe during the winter than they would be during the summer? Something like that. I mean, extreme cold. So just kind of wrapping up. This is a figure showing the reported natural disasters by type. And I want you kind of just to focus on the two major ones here, flooding and extreme heat. And so it's pretty clear that these types of disasters are definitely increasing over time. There's a couple on here that are not really increasing that we wouldn't really expect to change with climate change, such as volcano eruptions, stuff like that. If you look closely, you'll see that wildfires are also increasing over time, which is definitely a big concern. It has been in the news a lot. So these extreme events are certainly increasing a lot with climate change. So I'll just return to this panel of seven simple actions to help birds. And then that kind of needs to be paired, not just, those actions that anyone could do to help birds just in your yard by keeping the cats away, making the windows safer, etc. But we also need to be thinking about ways to fight climate change if we care about birds. So all these different steps that can be taken to help fight climate change are pretty important. And so I know this talk can be a little bit of a bummer at times, so I just wanted to end on some positive stuff right here. And so this is an article that just came out in the news quite a bit the last few weeks, showing that up to 48 species have been saved from extinction by conservation efforts. So this is really important, showing that some of these extinction rates for birds and mammals since 1993 would have been 3 or 4 times higher without action. So our actions are definitely making a difference. And then one more bit of good news, you might have heard that the Migratory Bird Treaty Act had been under fire a little bit by the federal government, but there was a ruling that preserved the act and corporations won't be allowed to ignore birds when they're making decisions that could affect bird mortality in large numbers. So birds really have to be taken into account based on this Migratory Bird Treaty Act. And so once again, I'd just like to thank Ben Zuckerberg and Daniel Fink, as well as Wisconsin, the Cornell Lab of Ornithology, and NASA and eBird for providing the data. And you can follow me on Twitter at Dr. Dribs. I'm over there in the corner, or Instagram to see photography, JC Nature. Thanks.
All right, thank you. We're gonna go through a few of the questions, and if anyone else has any questions that come up as we go, type them into that comments box and we'll get to them. So one question that came up has to do with the wildfires happening and their effects on birds. Of course, I know that's not what your research is focused on, but I'm going to ask you to use your really smart brain to apply all of this
I'll try.
to the current context. So the question is, let me get to it again. Do you have a feel for how major fires out west are affecting birds and migration?
So as Brenna said, um, we didn't look at fires specifically. We also did not look at the Western US at all. We looked at the Eastern United States and Canada. Um, but I think the fires are definitely having a major effect on birds. Number one, destroying habitat that's really important for when the birds come back next year and expect to breed in those same locations. Some of that habitat's going to be gone. And so that's going to be a major problem. And then during migration itself, you might have heard of some of those die-offs that occurred in New Mexico. That was in the news about 2 weeks ago, where a lot of birds were found in New Mexico, and it was only migratory birds that were found dead. There was no resident year-round birds in New Mexico that were found um, as casualties in this incident. And there's two reasons that I think are kind of convincing in terms of what could have been the cause of that. And the first one has to do with wildfires. Some of these birds migrate along the West Coast. And so with the fires, they might have been pushed inland and had to migrate much longer distances than they had, their energy budgets set up for. So it could have been kind of difficult to find food over large areas that were burning. And then the second one doesn't really have to do with fires, but just about 2 or 3 days before that happened in New Mexico, there had been an extreme temperature drop in Colorado where it was around 100 or 97 degrees for a couple days, which was a record for September. And then immediately following that, temperatures dipped to 35 degrees and it was snowing. There was a blizzard. And so, these birds are winter in the tropics. They're not used to seeing snow or cold temperatures at all. They're trying to migrate in September before it's ever experiencing those conditions. And so that kind of extreme variability that can occur with climate change that we're seeing more and more of, that could have been responsible, especially because Colorado is just north of New Mexico.
Great, thank you. Sort of along the same lines, not specific to your research, but the event of hurricanes is not unusual, right? And so are there ways that birds cope with those extreme weather events that are more hurricane based?
Well, birders get a little bit excited sometimes when there's hurricanes because they can blow rarities to really, really far-flung places. I think there was like a sooty tern found in Madison a couple months ago, maybe last month or 2 months ago, which is a Caribbean open ocean bird that should not be anywhere near Wisconsin, but it was here just because hurricanes. There have been a couple of frigate birds, which are also open Caribbean birds that are usually in the Gulf or the Caribbean. And those were found in Michigan and a couple other places, Ohio, recently, thanks to hurricanes. The unfortunate side of that is the birds don't really do too well since they're so far from home. And so these types of events can really blow birds really far from where they're supposed to be. I don't generally think of hurricanes as causing major mass mortality events in the same way as some other disasters, but birds that get caught up in them usually don't fare too well afterwards.
Mm-hmm. Yep, understandable. Someone has a question about what types of tools you use in your research. Like when you're crunching all these big numbers, what types of infrastructure do you have to look at all of this?
I spend a lot of time on the computer for sure. The only data I collect is I do contribute lists to eBird, so I go out quite a bit, but obviously that's a very, very tiny fraction of the amount of data that I'm using that I've actually collected. So I'm using mostly a statistical package called R, which is a free software that a lot of researchers use, especially for high-end computing of large databases and statistical data. So that's been used more and more in biology, especially. So that's what I usually use for most of these analyses.
Sure. Okay. Someone has a comment. I'll read it to you. I'm surprised long distance migrants are doing well given the phenological mismatch and have to deal with potentially extreme climate changes at different stages on their migration. Is there mobility an advantage here?
So I guess I should just clarify. We're not really saying that long distance migrants are doing well overall. It's really more that extreme extreme heat in June is not one of the factors that we have found to be contributing to their problems, which is a long list of other problems. Um, so long distance migrants are suffering, one of the major reasons is because of those window collisions. Whereas residents, they're not migrating long distances, so they're much less likely to crash into windows like that. So that's one example. Loss of habitat along the migration route is another major example of why migratory birds are not faring so well overall. And I just talked about that New Mexico example. So dealing with extreme climate fluctuations during their journey, especially extreme cold fluctuations like that, could definitely be an impact for them. But I wouldn't put extreme heat along their list of concerns as it would be for residents.
Okay, great. Thanks for the clarification. So that's all we have for questions. But like I said, if you're watching this later and you want to add a question into the comments box, we'll answer it as soon as we're able to. And Jeremy, thank you so much for being here. We really appreciate you sharing your knowledge, and we appreciate everyone watching for sharing their time. And thank you all. We'll talk to you soon.
Great. Thanks for having me.